Molarity is defined as the number of moles of a solute present per liter or dm cube of a solution. It is denoted by capital M, and thus capital M molarity is equal number of moles of solute upon volume of solution in liter. Let's say WB gram of solute is present in V liter of solution, and let's say Mb is the molecular weight of the solute. Therefore, number of moles of the solute is equal to given mass by molar mass, Wb upon Mb. Thus, molarity is number of moles upon volume in liter, which is V. Therefore, Wb upon Mb into V. Here, V is taken in liter unit or dm cube unit. If we use volume in cc, centimeter cube, or ml, then molarity becomes Wb upon Mb into V into 1000. So this is how we calculate molarity when volume of solution is given in ml. There is another technique of calculating molarity when density of the solution is given and mass percent is given. So let's say X% is the mass percent of the solution. Therefore, we can say obviously X gram of solute is present in 100 gram solution. Let's say D equal to the density of the solution in gram per ml. Now, mass of the solution one liter. So it will be 1000 into D, because we know, as we know, mass equal to volume into density. Volume is 1 liter or 1000 ml, and density is D gram per ml. So the mass of 1 liter of solution is 1000 D, correct? Now, in 100 gram solution, mass of solute equal to X gram, because X% is the mass percent. Therefore, 1000 D gram solution, the mass of solute will be x upon 100 into 1000 d. So this becomes x into 10 into d gram. So this much amount, this much mass of the solute is present in. So what is this? This is 1 liter. The mass of 1 liter of solution is 1000 d gram. Therefore, in 1 liter solution, x into 10 into d gram of the solute is present. Therefore, mole number of solute equal to given mass by molar mass. What is the given mass? X into 10 into d. Molar mass, we remember mb. Therefore, molarity equal to number of moles upon volume, which is 1 liter. So 1 in liter unit. So we can say this is x into 10 into d upon mb. This is another important formula. Next is molarity after dilution. So what is the idea? Let's say you have a solution. The volume is V1 and the molarity is M1. Now what you have done, you have added some water. Water is added. So some solvent is added actually. But we haven't added any solute. So as a result, we have produced this solution where the volume becomes V2, which we understand how much? V1 plus volume of water added. This is the volume V2 and molarity, it becomes M2, let's say. Now, what is the idea? So in this particular case, initially, the number of moles of solute. What is the number of moles of solute? So we know molarity equal to number of moles by volume in liter. Therefore, N equal to M1 into V1. Number of moles equal to molarity into volume. This we know. And from the final mixture, we have M2 equal to N by V2 or N equal to M2 into V2. N is fixed. Why? Because we haven't added any solute. No solute is added. Only water or the solvent is added. Therefore, we can write M1 into V1 equal to M2 into V2 or M2 final molarity equal to M1 V1 upon V2. This is molarity after dilution. Next, molarity of mixing. Let's say we have a solution having volume V1, molarity M1. It is mixed with another solution having volume V2 and molarity M2. So they would produce this solution whose volume becomes V1 plus V2 obviously, and the molarity, let's say it is MR, resultant molarity. Now the number of moles, first of all, number of moles of solute is M1 into V1. So let's say it is N1 into number of moles of solute in the second, for the second solution is M2 into V2. Therefore, the number of moles in the resultant mixture will be N1 plus N2. This is the total number of moles of the solute. Therefore, we can write N1 plus N2 equal to N1 plus N2. Alright, or we can write M1 V1 plus M2 V2. What about N1 plus N2? N1 plus N2 is equal to MR V1 plus V2. Correct? Therefore, MR, resultant molarity, equal to M1 V1 plus M2 V2 upon V1 plus V2. So let's say you have taken three solutions. Then the molarity will be M1 V1 plus M2 V2 plus M3 V3 upon V1 plus V2 plus V3, and so on. Next, the relation between molarity and mole fraction. Chi or X. So first is, what is mole fraction? Mole fraction of a component A is the mole number of A upon total mole number of solute and solvent. So generally, mole fraction of A equal to mole number of A by mole number of A plus mole number of B. Similarly, mole fraction of B is mole number of B upon mole number of A plus mole number of B. Okay, generally for A, by A we represent solvent and by B we represent solute. So if we are talking about the mole fraction of a solute, that is equal to Nb upon Na plus Nb. Okay, where Na is the mole number of solvent and Nb equal mole number of solute. So if mole fraction is given, how do you calculate the molarity? Molarity equal to chi B therefore molarity equal chi B into 1000 into D upon chi A Ma plus chi B Mb, where we know D equal to density of the solution in gram per ml unit. Alright. If we need to use only Chi-B, then molarity becomes Chi-B into 1000 into D. In place of Chi-A, we can write 1 minus Chi-B into MB plus Chi-B into MB. Chi-B into MB. Why? Because as we know, Chi-A plus Chi-B equal to 1. So mole fraction of the solute plus mole fraction of the solvent equal to 1. Therefore, Chi-A equal to 1 minus Chi-B. This is the relation between molarity and mole fraction.